Some people are still a little confused, so I am going to go through the stoichiometry again with you. If you're not confused, you can just fast forward through that part. The first thing I want to say is this is our most difficult unit. A lot of people have a lot of problems with this. Please private message me so we can work on the worksheets together. We started out with this mole island, and this is for one substance. And what does that mean? I'm just talking about carbon. If I want to change grams of carbon to moles of carbon, this is the worksheet that I use, the mole island. Notice, grams per 1 mole. Number of molecules per 1 mole. 24 liters is in 1 mole of any kind of gas. So whenever you're going from volume of substance A to moles of substance A, or backwards, meaning same substance conversions, it should always be 1 mole. Some people here put 22.4 for 2 moles. That's not a true statement. Some people put 44.8 liters for 2 moles. That is a true statement, but you just did a bunch of math that you didn't have to. 44.8 for 2 moles is a true statement, and it is correct. But there's no reason to double it because the coefficient was doubled. These conversions have nothing to do with the coefficient. So let's look at our full stoichiometry mole island. What we just looked at, so this one substance conversion is this side of the chart. That's for substance A, okay? So you could put right on here if you wanted to. Let's see if I can make any pencil work. That'd be nice. So if I'm going for gas volume, it's 22.4 liters for 1 mole, right? Here on this side, this is for one substance. This is for substance B. Gas volume, 22.4 liters per 1 mole, of course at STP. That's right from our chart, and you can fill these in there. When do we use the coefficients from the balanced equation? That's when we're going from substance A to substance B or back. And right here, this is where we use the coefficients from the mole ratio. So we just follow your mole island. If you're going from grams of substance A to moles of substance A, here's your conversions, and you can write them in right here. Only use the coefficients when we're going from moles of A to moles of B in that balanced equation. You have this worksheet, and I am going to do the work right here. What is percent yield? Well, let's say that I own a company, and let's say I'm making hand sanitizers. I'm making isopropyl alcohol. I'm going to start with some reactants, and I'm going to want to make the isopropyl alcohol from those reactants. If I calculate how much reactants I use, I can figure out how much products is formed. But that didn't actually happen. That was theoretical. Our calculations are all theoretical. Okay, so percent yield is how much you should have made compared to how much you actually made. So why would we not make exactly 100%? Well, there's many factors. First of all, what you don't know is some of these reactions don't always go all the way to completion. Some of those have products and reactants, and they never get all the way there. Our products will break down back into reactants, and our reactants will go back into products, and they hang out somewhere in the middle, and that's called equilibrium. Okay? And these double-sided arrows means we have an equilibrium. So for ammonia, if I use 1 mole of ammonia and 3 moles of hydrogen, it won't make 2 whole moles. It won't go all the way here. It won't finish. It'll make some ammonia, and that ammonia will break back down and go back into reactants. Okay, but that's another lesson. What you do need to know is that these are equilibrium. Equilibrium means the reaction settles somewhere between reactants and products. Okay, and you'll have some questions at the end of this worksheet. Another factor is human error. We have Joe Schmo. He's making our reaction, And then, oops, his hat falls into the reaction vessel. That's going to mess up the reaction, and we won't completely make all of our products. So there's human error. Okay? Stoichiometry is what we use to calculate products that should be made in a perfect world. Okay? Theoretical. It doesn't really happen. We calculated it. We didn't do it in a lab. We just did it on paper with math. That's what you've been doing. Every reaction that you've been doing stoichiometry is theoretical. You didn't really do it in a lab. Theoretical is what we calculate using stoichiometry. Okay? But then we can go to the lab and we can actually do this reaction. And our actual yield is how much product you actually made in the lab. Okay? And how do we know how much we made in the lab? We don't calculate that. We actually measure it. We get our products, we can weigh it, we can check our volume, however we're going to do those measurements. So the difference between theoretical yield and actual yield, theoretical is just your calculations, actual yield is what you actually do in the lab. Okay? So now we need to talk about percent. Percent is always a part over whole. Okay? So here I have kind of a representation of a pizza, and let's say I cut this pizza into 4 pieces, and you have a really annoying little brother and he eats 3 of the 4 pieces and you only get 1. If your brother ate 3 of the 4 pieces, you might be able to quickly do in your head, he ate 75% of the pizza, you only have 25% of the pizza. Another way to think about that is there's 4 quarters in a dollar. Okay, we took our dollar, we cut it into 4. 3 parts of that dollar is 75 cents. So part over whole times 100 is always percentage. It doesn't matter what kind of percentage you're talking about. That's the definition of percent. Okay, so if we look at your annoying brother who ate 3 out of the 4 pizzas times 100, that gives us 75%. And you only got 1 out of 4 pieces, that's 25%. And that's just a reminder of what percentage is. You guys should have all done that in math class. Okay? So, percent yield is, what is percent? It's part over whole. Theoretical yield is what you should have made. Theoretical is the whole, and actual yield is the part. Actual yield is what actually happened in the real world, and theoretical is the amount you should have actually made, the whole amount, times 100. That's all that percent yield is. You calculate what you should make using stoichiometry, and then you use that and compare it to what you actually made. So actual over theoretical times 100 is percent yield. Okay, now, why is that important? Well, every company wants to get every part of their reaction to work out perfectly so they get 100%. Otherwise, there's waste and you lose money, and then that would be bad. You want to maximize the amount of money that you can make. So all companies calculate their percent yield. The lower percent yield, the less money they make, right? If you have a lot of waste and your reactants aren't all turned into products, that means you lost some reactants somehow and you're not making enough money. If Joe Schmo, the guy who lost his hat in that kettle, has a percent yield of 89% or lower, he will probably be fired. When I worked, our percent yields were up around 97 and above. Okay, so if they were lower, you had somebody who didn't know what they were doing when they were running that reaction. So this is our formula that you want to use, and you want to make sure that you are plugging it in correctly. So, number 1, a company calculates it can theoretically make 250 grams. Why is it theoretical? Because they calculated it. It didn't actually happen. Okay? And they're making nylon with reactants in the warehouse. When the reaction is complete, 200 grams of nylon was actually made. Okay? So they didn't make as much as their calculations showed them. So what's the percent yield? Well, percent yield is actual divided by theoretical, and I have a theoretical, times 100, I always forget that, okay, and I have a theoretical of 250 grams of nylon, and I made 200 grams of nylon. Most importantly, they have to be in the same units, okay? So now, plug that in your calculator, and you're going to get 200 divided by 250, and don't forget to times it by 100. I automatically always do that. And you are going to get an 80% yield, okay? So it's just that simple. Find your actual, which is going to be given to you, or it would be given to you with lab data. Now I'm not doing any lab data now because we're doing this COVID thing and I don't have enough time with you. So this actual, they're going to tell you what was actually made in the lab. Theoretical, you're going to calculate that using stoichiometry just like we've been doing. Okay, so answer number 2, tell me what is meant by theoretical, and do number 3 on your own, okay? Now, we are going to get into our problems where they don't give you the theoretical. Theoretical is calculated using stoichiometry, so we're going to have to do that. 5.6 grams of hydrogen gas reacts with excess oxygen. That just means I have plenty of oxygen and the reaction will completely react with all of the hydrogen, okay? So if it says excess, we don't care about it. How many grams of water will be produced? That's part A. If 25 grams of water are actually produced, what is the percent yield? So this goes with our percent yield problem, but first, step 1, we need to calculate using stoichiometry what should be produced. How much product will we make? We need to start with a balanced equation. Hydrogen reacting with oxygen makes water. How do we balance this? Well, I have 2 hydrogens, 2 hydrogens, 2 oxygens, only 1. I'm going to put a 2 there. Okay, but now I have 4 hydrogens, so I have to put a 2 there. I have 2 oxygen and 2 oxygens. We're all good. This equation is going to come back up in later problems. Make sure you know how to write a balanced equation making water. Our second step in stoichiometry is to ID. Well, they said 5.6 grams of hydrogen is reacted with excess oxygen. So what did they give us? They gave us 5.6 grams of hydrogen. Okay, this is below hydrogen, so I know what I'm solving for. If you don't ID it right, you will be losing some points. Okay, and how many grams of water will be produced? Question mark produced. Sometimes they don't ask you how many grams of water, so how do you know what to solve for? Well, if I have grams of water produced, I need to find grams that are theoretically produced. So question mark in grams. Okay, so now I want to go through the stoichiometry with you one more time. We have 5.6 grams of hydrogen gas. Okay, so, and I need to find water. So my substance A here is hydrogen gas. And I'm starting with 5.6 grams. Okay? And then what do they want me to find out? How many grams of water will I produce, which makes B water. My first step is to go from grams to moles. And then I need to go from moles of A to moles of B. And this is where I use my coefficients. And then I'm going to convert that moles to grams. I don't use my coefficients there. Okay? So I'm going from grams of hydrogen to moles of hydrogen to moles of water to grams of water. And that is the path I just drew on here. Okay? If you get lost doing stoichiometry, put your hand on what you're given, put your hand on what they're asking for, and draw a path. And that is how everyone who gets lost figures out how to do it. They tell me I'm lost, and I tell them to put their hands on this map, and instantly they know what they're doing. So make sure you follow this. Okay, so I have 5.6 grams of hydrogen. Here I am, grams of hydrogen island. Do I want to stay on grams of hydrogen island? No. Where am I going? Moles of hydrogen. I'm still on substance A. How do I get off grams of hydrogen? Well, I put it right down there, and I go to moles of hydrogen, and my path is every place I want to go. What is my conversion factor? That's on our single mole island. I'm going from grams to moles. How many grams are in 1 mole? Well, hydrogen gas is 1.01, so I have 2.02 grams for every 1 mole. Okay, good. And I have 3 islands, so I could put all my conversions there so I know what I'm doing. Do I want to stay on moles of hydrogen? No. And where am I going to? I'm going to moles of water. This is my path I drew. Follow along on your mole island. Okay, now I don't have to put in my conversions yet. I can just keep drawing this. Do I want to stay on moles of water? No, so I put it on the bottom. I'm still making my conversions, and I want to finally end up grams of H2O. And then you could go back and fill this in. When I'm going from moles of substance A to moles of substance B, this is where I use the coefficients from my balanced equation. Moles of one substance to moles of the other. Water. Water has 2, that's the coefficient, and hydrogen has 2, that's the coefficient there. Okay? Now, I am going from one substance, grams of moles of water to grams of water. That would be your one substance conversion, which you can write on here. This is grams per 1 mole, and where do I get this? I get this from the molar mass from the periodic table. Okay, so when I add that all up, for every 1 mole of water, I have 18.02 grams. How do I put this in my calculator? Whatever's on top I multiply, whatever's on the bottom I divide. Every single one of these is just a 1-step conversion, and we strung them all together. So I have 1, 2, 3 conversions. I went from 1 to 3 islands. Okay, so put this in your calculator and see if you can get what I get. So you should have gotten 49.956 blah blah blah. Here I have 1, 2 significant figures, 1, 2 significant figures. That would round it to 50. And I have to put the decimal there, so I have 2 significant figures. So 50 decimal grams of water. Okay, and that was my answer with units, 50 grams of H2O. And since I calculated that, that's theoretical. Okay, what should be produced is theoretical. Theo for short. Okay, so now, step 2. Calculate the percent yield. Well, we just figured out what my theoretical was, and that's 50.0 grams of H2O, and it says if 25 grams of water was actually produced, that's my actual. What's the percent yield? So 25 grams was my actual, 50 is what we just calculated, times 100 will give us 50% yield. Okay, and would Joe Schmo be fired? Yes, 50% yield's really, really bad. Okay, your company's not making a lot of money with a 50% yield. I'm doing number 5 with you also, so let's do that problem. So this says 40 grams of water are actually produced, okay? That's not part of my calculations. That is part of my percent yield, and that's my actual yield. This is produced in the lab when 48 liters of hydrogen gas are used to start the reaction. So what's the percent yield? The first thing you have to do is you need to calculate what should be produced. So I put this problem on here because I want you to know that they gave us grams of ammonia, which means I need to compare it to grams of ammonia. But we did start with 48 liters of hydrogen, and we're going to make ammonia. So my balanced equation is N2 plus H2 is going to make NH3. How do I balance that? I put a 2 there, I put a 3 there, and I'm balanced. So now, I started with 48 liters of hydrogen gas, and that is going to be at STP, unless they tell you differently. And then, what am I solving for? They don't really tell me, but since my actual yield was grams of ammonia, I need to compare that to my theoretical yield, grams of ammonia. Okay, so that's how you figure out what you're solving for when they don't explicitly state it. Okay, so I ID'd that, and what do I start with? Well, first of all, let's look at our path. Not that one. I'm starting with ammonia. I'm gonna kind of erase my path here. Okay, we are starting right here. Our substance A is 48 liters of hydrogen gas. Okay, so that's hydrogen gas, and I'm solving for ammonia. I'm starting with 48 liters, so I'm starting here. Okay, and where am I solving for? I'm solving for grams of ammonia. So that means I need to go one conversion to, I need to convert liters of hydrogen to moles of hydrogen. And here's where I go from one substance to another. I'm going from moles of hydrogen to moles of ammonia. And then I'm converting moles of ammonia into grams of ammonia. You use your coefficients only when you go from moles to moles. Okay, so my work. I start with 48 liters. Let's put our path. Liters of H2 to moles of H2 to moles of my B substance, which is ammonia, and then they want me to make that grams of ammonia. Okay, so that's my path. 1, 2, 3 conversions. I start with liters of H2 gas. Do I want liters of H2 gas? I do not. How do I get rid of it? I put it on the bottom, and I am going to moles of H2 gas. Now I'm going to set up all my conversions before I plug in the number, but you can do it where you put the numbers in right away. Do I want to stay on moles of hydrogen island? How do I get off? That's how I get off if I don't want it. And I'm going to moles of ammonia. But my question didn't ask for moles of ammonia, so I need to get rid of moles of ammonia, and I need to convert moles of ammonia to grams of ammonia. And now I can plug in my conversions. How do I know it's set up right? Well, my liters of hydrogen is gone, my moles of hydrogen is gone, and my moles of ammonia is gone, and I'm left with grams of ammonia, and that is what I'm starting for. I ID'd it right here. So, how many liters per mole is there? That is our single substance. Liters to moles, moles to liters, 22.4 liters for every 1 mole. 22.4 liters for 1 mole. Now I'm going from moles of one substance to moles of another, and that is coefficients from the balanced equation when I'm going from moles to moles. Ammonia has a coefficient of 2, and hydrogen has a coefficient of 3. And now I need to go from one substance to one substance, so I do not need my coefficients. For every 1 mole of ammonia, there is 17.03 grams of ammonia. Nitrogen is 14 grams. Hydrogen is 1.01. There are 3 of them. That makes that 3.03 plus 14. That gives me 17.03 grams. Plug this in your calculator and see if you get the same number that I do. That's how you know you're doing it right. So you should have gotten 24 grams of ammonia, 24.328, blah, 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 blah. Here I put 40 grams. I should have put 40 with a parentheses. I always want 2 sig figs. So 2 sig figs, 2 sig figs, 2 sig figs. My answer with units is 24 grams of ammonia. And I calculated that. Since it didn't actually happen in a lab and it was calculated, that is my theoretical yield. Okay, so what do we do with that? Well, we need to calculate our percent yield. We just found our theoretical was 24 grams, and our actual yield is 40 grams. Okay, that's where I actually want that. And we made way more than we should have. That's weird, but I'm going to leave it there. And normally that wouldn't happen. Divided by 24 is going to give us 166%. So something must have got in there for you to get over 100% yield. That should never happen, but odd problem. And they just want you to be aware that that is very strange to get over 100%. So now you have 6, 7, and 8 to do on your own. And then you have some questions based on your reading. This will be graded based on correct answers. Okay, so read what you have at the beginning. The answers to 6, 7, and 8 are right here, so you can check that you're doing your work properly. Put it in your calculator. You can write down these answers, but it's not going to show you if you set it up right. The only thing that'll show you if you set it up right is if you put it in your calculator and check it.